National Electrical Code Section 408.8 MB requires concealed wires to be installed in raceways or other approved enclosures. National Electrical Code Section 408.4b prohibits the use of flexible cords as a permanent wiring method. The exposed wire running to the domestic water heater is a violation of National Electrical Code Section 408.8 b because it is a concealed wire that is not installed in a raceway or other approved enclosure. Additionally, the wire appears to be a flexible cord, which is not permitted for use as a permanent wiring method according to National Electrical Code Section 408.4b. Consequences of these violations include electrical shock hazard, fire hazard, and code violations. The wire should be removed and replaced with a concealed, properly enclosed, and non-flexible wiring method. This could involve installing a raceway or conduit to protect the wire. Let's delve deeper into why these code sections are important and how to ensure electrical safety in your home. The National Electrical Code, or NEC, is a comprehensive set of guidelines and regulations designed to ensure the safe installation and maintenance of electrical systems. It covers a wide range of topics, from wiring methods to grounding and bonding, and is regularly updated to reflect the latest technological advancements and safety concerns. Adhering to the NEC is crucial for preventing electrical hazards and protecting both people and property. National Electrical Code Section 408.8 b, which mandates that concealed wires be installed in raceways or other approved enclosures, is in place for several reasons. Firstly, it provides physical protection to the wires, shielding them from damage caused by abrasion, impact, or environmental factors. This is particularly important in concealed locations, such as within walls or ceilings, where wires may be more vulnerable to accidental damage. Secondly, raceways and enclosures help to contain any potential electrical faults, preventing them from spreading and causing fires or electrical shocks. By providing a grounded metal pathway, they ensure that fault currents can safely return to the source, tripping a circuit breaker or ground fault circuit interrupter, or GFCI, and energizing the circuit. Thirdly, raceways and enclosures make it easier to access and maintain the wiring system. They allow for the addition, removal, or replacement of wires without having to tear open walls or ceilings, saving time and money in the long run. Approved raceways include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and non-metallic conduit. Approved enclosures include junction boxes, pull boxes, and cabinets. The choice of raceway or enclosure will depend on the specific application and the type of wiring being used. National Electrical Code Section 408.4b, which prohibits the use of flexible cords as a permanent wiring method, is based on the fact that flexible cords are not designed to withstand the rigors of permanent installation. Flexible cords are typically made of stranded conductors with a thin layer of insulation, making them more susceptible to damage from abrasion, heat, and chemicals. They are also more likely to become loose or disconnected over time, creating a potential fire or shock hazard. The National Electrical Code defines a flexible cord as a cord that is designed to be used for temporary wiring applications, such as connecting portable lamps, appliances, and tools to a power source. Flexible cords are not permitted to be run through walls, ceilings, or floors, or to be used as a substitute for permanent wiring. Permanent wiring methods include non-metallic sheaths cable, armored cable, and conduit wiring. These wiring methods are designed to be installed in a permanent manner and to provide a safe and reliable electrical connection. In the case of the exposed wire running to the domestic water heater, the violation of National Electrical Code Section 408.8b and 408.4b poses several risks. The exposed wire is vulnerable to damage from physical contact, moisture, and temperature changes. This could lead to a short circuit, ground fault, or even a fire. The use of a flexible cord as a permanent wiring method is also a concern, as it is not designed to withstand the stresses of continuous use. The cord could become frayed or damaged over time, creating a potential shock hazard. To correct these violations, the wire should be removed and replaced with a concealed, properly enclosed, and non-flexible wiring method. This could involve installing a raceway or conduit to protect the wire, or using a non-metallic sheath cable or armored cable. The wiring should also be properly sized for the load and connected to a properly sized circuit breaker or fuse. When selecting a wiring method, it is important to consider the specific application and the environment in which the wiring will be installed. For example, in wet or damp locations, a waterproof wiring method should be used. In areas where the wiring may be exposed to physical damage, a rugged wiring method should be used. It is also important to ensure that the wiring is properly grounded and bonded. Grounding and bonding help to protect against electrical shock and fire by providing a low impedance path for fault currents to return to the source. Grounding and bonding also help to reduce electrical noise and interference. In addition to the specific code sections mentioned above, there are a number of other national electrical code requirements that apply to wiring installations. These requirements cover topics such as conductor sizing, overcurrent protection, grounding and bonding, and wiring methods. It is important to consult the National Electrical Code and other applicable standards to ensure that all wiring installations are performed safely and in accordance with code. Here are some additional considerations for ensuring electrical safety in your home. Regularly inspect your wiring for any signs of damage such as frayed insulation, loose connections, or corrosion. Replace any damaged wiring immediately. Use ground fault circuit interrupters, or GFCIs, in wet or damp locations such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to protect against electrical shock by quickly de-energizing a circuit when a ground fault is detected. Install arc fault circuit interrupters, or AFSIs, in bedrooms and other areas where electrical fires are more likely to occur. AFSIs are designed to protect against electrical fires by detecting arc faults, which are a common cause of electrical fires. Use surge protectors to protect your electronic equipment from power surges. Power surges can damage or destroy electronic equipment, such as computers, televisions, and appliances. Have your electrical system inspected by a qualified electrician on a regular basis. A qualified electrician can identify and correct any potential electrical hazards. When performing any electrical work, always disconnect the power to the circuit being worked on. Use a voltage tester to verify that the power is off before starting any work. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Follow all safety precautions when working with electricity. Electricity can be dangerous if not handled properly. By following these guidelines, you can help to ensure the electrical safety of your home and protect yourself and your family from electrical hazards. Let's look at some examples of how National Electrical Code Section 408.81b and 408.4b apply in different situations. In a residential setting, running an exposed wire across an unfinished basement ceiling to power a light fixture would be a violation of National Electrical Code Section 408.81b. The wire should be installed in conduit or cable and secured to the ceiling joists. Similarly, using a flexible extension cord as a permanent wiring method to power a window air conditioner would be a violation of National Electrical Code Section 408.4b. The air conditioner should be wired directly to a dedicated circuit using a permanent wiring method. In a commercial setting, running exposed wires through a suspended ceiling to power recessed lighting fixtures would be a violation of National Electrical Code Section 408.81b. The wire should be installed in conduit or cable and supported by the ceiling grid. Likewise, using a flexible cord to connect a cash register to a power outlet on a countertop would be a violation of National Electrical Code Section 408.4b. The cash register should be wired directly to an outlet using a permanent wiring method. In an industrial setting, running exposed wires along a factory wall to power machinery would be a violation of National Electrical Code Section 408.81b. The wires should be installed in conduit or cable and secured to the wall. Also, using a flexible cord to connect a portable power tool to a power source on the factory floor would be a violation of National Electrical Code Section 408.4b. The power tool should be connected to a permanent power outlet using a cord that is specifically designed for industrial use. Understanding and adhering to these code sections is critical for ensuring electrical safety in all types of buildings. Failing to do so can result in serious consequences, including electrical shocks, fires, and code violations. Remember that electrical codes can be complex and may vary depending on local regulations. If you're unsure about any aspect of electrical wiring, it is always best to consult with a qualified electrician. They can help you to ensure that your electrical system is safe and up to code. By prioritizing electrical safety, you can protect yourself, your family, and your property from the dangers of electricity. Let's now discuss the potential consequences of ignoring these electrical code provisions and using improper wiring methods. Firstly, electrical shock is a serious hazard that can occur when a person comes into contact with an energized wire or component. The severity of the shock depends on the amount of current flowing through the body, the path of the current, and the duration of the contact. The electrical shocks can cause burns, muscle contractions, respiratory arrest, cardiac arrest, and even death. Secondly, fire is another significant risk associated with improper wiring. Overloaded circuits, loose connections, and damaged insulation can all lead to overheating and ignition of surrounding materials. Electrical fires can spread quickly and cause extensive damage to property and pose a serious threat to life safety. Thirdly, code violations can result in fines, penalties, and legal action. Building inspectors and electrical inspectors have the authority to issue citations and require corrections for any violations of the electrical code. Failure to comply with these requirements can result in delays in construction projects, increased costs, and even the shutdown of businesses. In addition to these direct consequences, improper wiring can also have indirect effects on the value and safety of your home or building. For example, a home with known electrical code violations may be difficult to sell, and it may also be more difficult to obtain insurance coverage. Similarly, a building with a history of electrical problems may be less attractive to tenants and may also be at a higher risk of liability claims. Therefore, it is essential to take electrical safety seriously and to ensure that all wiring installations are performed in accordance with the National Electrical Code and other applicable standards. By doing so, you can protect yourself, your family, and your property from the dangers of electricity and avoid the costly consequences of code violations. In summary, the exposed wire running to the domestic water heater is a clear violation of National Electrical Code sections 408.8b and 408.4b. This situation presents an electrical shock hazard, a fire hazard, and potential code violations. The recommended action is to remove the exposed wire and replace it with a properly concealed and non-flexible wiring method, such as installing a raceway or conduit. Always prioritize safety and consult with a qualified electrician to ensure compliance with all applicable electrical codes.